APAB Calc. We're doing 2.4, which is the chain rule, and this is our second video in this section. So we're just going to apply the chain rule a bunch of times to a bunch of different questions, and then we'll get to some other problems that maybe involve a little bit more context. But for right now, we're just going to apply the chain rule. So in E2, I give you that f of x is e to the 3x, and this is the first time I'm making you use that exponential derivative that we learned on a note card the other day. So we're going to find f triple prime of x. So that's going to involve differentiating 3 times. And each time we do that, we're going to see that we have to apply the chain rule. So let's start right here, and I'm just going to go ahead and find f prime. So using the chain rule, the thing to notice is that my inside function is almost always the one with the x, right? It's my inside function is 3x. And my outside function is e to the stuff, right? So e to a power is my outside function, okay? So the derivative of the outside is going to be e to the stuff, right? Because that's the derivative of e to the x is e to the x. The derivative of e to the stuff is e to the stuff. And then times the derivative of the inside is just going to be a 3, because the derivative of 3x is a 3. So what I'm going to get is that my f prime, so f prime of x is just a 3 e to the 3x, right? So when I differentiate the next time, right, what's going to happen is exactly the same thing, in fact, if you notice, because my f prime is basically this exact same function, but with a 3 sitting in front of it, right? So so my f double prime, right, my f double prime of x is going to be, well, now there's a 3 e to the 3x, right? That's the derivative of the outside. Actually, let me do my color coding for you, right? So I still have a chain rule, right? I still have this inside function, right? I still have an inside function, and I still have the whole outside function, which is 3 e to the stuff. So the derivative of the outside function is going to be 3 e to the stuff, right? Derivative of the e to the stuff is still just e to the stuff, times the derivative of the inside function, which is going to be times a 3. So I'm going to get that my f double prime is a 9 e to the 3x, right? And then when I go to find the third derivative, which is the one that I was actually asked to find, right? It's going to be the same idea, right? I'm going to derive 9 e to the stuff, right? So the derivative of the outside is just going to be that 9 e to the stuff, because the derivative of e to the stuff is just e to the stuff, times the derivative of that stuff, right? So I'm going to end up with a 27 e to the 3x. Now, this is one of those situations, and that's my f triple prime, right? I kind of ran out of room, but you get the gist. This is one of those situations where actually I could predict what later derivatives would look like, right? If I wanted to, I notice that each time I differentiate, because of the chain rule, I'm multiplying by 3. So if I wanted to predict, I notice that the first derivative has a 3 to the first as the coefficient, and the second derivative has a 3 to the second, and the third derivative has a 3 to the third. So if you were asked to do so, and you're not here, but if you were, you could actually figure out that the nth derivative of this thing would be a 3 to the n times that e to the 3x, right? So if I wanted the 10th derivative, it would turn out that there's a 3 to the 10th there. Now, I'm not going to make you do that, but just to show you that that's a possibility. So if you want to pause me, you can go ahead and pause me to try P2, right? P2 is similar to E2, except instead of an e to the 3x, we have a sine of 6x. So pause me now if you want. I'm going to go ahead and do the problem. So my inside function is usually the one that has the x, right? My outside function is the sine of some stuff, right? So when I differentiate the first time, right, my g prime of x is going to be the derivative of the outside times the derivative of the inside. So the derivative of sine of stuff is cosine of the same stuff. So derivative of sine is cosine. Since it was a sine of 6x, it's going to be a cosine of 6x, times the derivative of the stuff on the inside, which will just be the derivative of 6x, or 6. So essentially what happened is I just ended up multiplying my derivative by 6 because of the chain rule, right? All right. When I go to differentiate again, right, again, I still have that same inside function. That same inside function is a 6x, right? And the outside function is a 6 cosine of stuff, right? So my outside function is 6 cosine stuff. Well, the derivative of cosine is a negative sign, so I'm going to get a negative 6 sine of the stuff, right? That's the derivative of the outside. And then I'm going to multiply it by the derivative of the inside, because again, if there's a function in your function, so derivative of the inside is a 6, so I'm going to end up getting that my final answer for g double prime, because that's how far I was asked to go here, was a negative 36 sine of 6x. Now here, I wouldn't easily be able to find the nth derivative, because we're going to have that cycle of sine derives to cosine to negative cosine, etc. but I can easily figure out what coefficient goes in the front, right? I can easily figure out that it's essentially going to be a power of 6. So yeah, that's kind of the idea. All right, so now let's walk through E3, and when I do that, I'm actually going to erase over here because I need some space. So hopefully you got all this. If you didn't, pause it. Make sure you have it down because I'm about to erase it. All right, so when we talk about E3, I'm now going to give you a function where there are not two functions. There's not an inside and an outside function, but there is a chain with 3 functions. So let's talk about E3. So for E3, I'm given f of x equals cosine cubed of 4x. So the big important thing when we start doing E3, which I'm going to move over here, right, is that we need to realize what cosine cubed of 4x actually means. It means the cosine of 4x entire quantity cubed. Like, that's how you would have to put it in a calculator, right? So I actually have 3 functions here, and conveniently I have a third color of marker. I have this inside function, which is typically the one with the x. I clearly have this outside function, which is the cubed, right? The stuff cubed is the outside function. But I also have this little level of function here in the middle. I have like a middle function, which is the cosine function, right? So if I want f prime, and I promise that as you do this, you get better at it, and it doesn't seem to require quite so much effort. I'm going to need the derivative of the outside times the derivative of the middle times the derivative of the inside, right? The whole chain. So the derivative of the outside is stuff cubed, right? Remember, the outside function was stuff cubed. So the derivative of stuff cubed is 3 stuff to the second. Well, the stuff is going to stay exactly the same. It's going to be a cosine of 4x, right? The middle function, right? The middle function, if I can get the correct color here, was a cosine of stuff. Derivative of cosine of stuff is negative sine of that same stuff, right? And then the inside function was the 4x. The derivative of 4x is a 4. So I end up with these 3 layers, and then I just clean this up so it doesn't look quite so disgusting, right? So when I clean it up, I'll move all the coefficients to the front. That includes the 3 and the negative and the 4. So I'm going to end up with a negative 12 cosine squared of 4x sine of 4x. And you really don't have to put the 4x in parentheses. It's implied that that's what that the whole 4x is included, but that's the gist. Okay, and I'm sure there's other acceptable ways to write that, but that's sort of the easiest way. So give P3 a try, right? P3 is secant to the 4th of 5x squared, and you're finding the first derivative. Now, you can try that without me. Go ahead and pause me, and I'm going to walk through it pretty much now. So pause me if you want to do it before me. So for P3, it's helpful to rewrite my g of x, recognizing that that 4th power is actually on the outside, right? So my inside function is usually the one that has the x, right? So my inside function, my middle function would be the secant, right? Sorry, that's the wrong color. There's a lot of colors here. Okay. So my middle function is secant, right? And then my outer function is stuff to the 4th, right? So my outer function is this 4th power. So now when I go to find my g prime, I'm going to have g prime of x equals, so the derivative of the outside function would be 4 stuff, oh, I forgot to color code, my bad, I'm the worst, sorry people. Okay, hold on. D out times D middle times D inside. Okay, so in purple, right, the derivative of my outside function would be 4 stuff to the 3rd, but the stuff was a secant of 5x squared, right? And then the derivative of the middle, well, the derivative of secant is secant tangent, meaning secant of whatever is inside the secant, tangent of whatever was inside the secant, right? That's the derivative of the middle, right? So that was d mid. And then the derivative of the inside is going to be a 10x. So this ridiculous ugly mess, if I clean it up, I notice that there's actually 4 of the secants now, because there's a secant cubed and there's another secant. So if I put the x and the coefficients at the front, I end up with a 40x, a secant to the 4th of this 5x squared, and a tangent of the 5x squared. And that's probably how you'd see it. Now, in a problem like this, the entire problem is just testing, did you understand the chain rule? Because they're not going to make you do anything with something this complicated, and you're probably not going to see a problem that looks like this if you're not in a section that's expressly testing your ability to do the chain rule. So that's the idea when you have a function in your function. Certainly these are slightly trickier versions of the 3-level function, and if somebody wanted to be a total jerk, they could give you a chain with like 4 or 5 functions, but it's just not realistically likely to happen. Now what I do want us to address though is when we have a chain rule that is a chain because of some products and quotients, right? So like when there's product and quotient stuff. So let's go ahead and walk through a slightly more complicated problem. So let's do, and just, again, you're not always going to see problems that look like this, but it's worth you seeing them with me before you stumble upon one in a book or on a test that's stressing you out, right? So let's go ahead and pick, let's do a quotient that has a chain. So let's do, let's do an x plus 2 divided by 2x minus 3 squared. Okay. Now, technically, you could FOIL out the bottom. It's not a great plan, right? So what we're going to do is we're going to find f prime of x, okay? So the issue here is that this is definitely a quotient, right? I have a high function, and I have a low function. But the low has a chain because there's clearly a function inside of another function on the bottom, right? So when I find my f prime of x, I'm going to need to do low d high, right? So this is low d high minus high, which is the x plus 2, right? D low. Well, now d low is going to be a chain because there is a function inside the function in the low function, right? So I'm going to get 2 stuff to the first power times the derivative of the inside, which is a 2, right? So in this situation, this was my outside function, right? This was my inside function. So this was my d inside, and this whole thing was my d out, okay? And then on the bottom, I need to square the low, which is going to be a 2x minus 3 quantity to the 4th. Now, when you go to clean this up, if you had to clean this up, the trick here is that the smartest, by far, smartest way to clean this up is to recognize that there is a GCF of 2x minus 3 on the top. This guy has a 2x minus 3, right? This is separating a different term, and this guy also has a 2x minus 3. So if you had to clean something like this up, you would want to factor out the 2x minus 3 GCF. What you would be left with if you did that on this first term is just the other 2x minus 3 minus, and then this is a 4 times the quantity x plus 2, which you can simplify pretty easily. On the bottom, you have a 2x minus 3 to the 4th, which we'll deal with in a sec. When you clean up this numerator, right, these leftovers that got left behind after the GCF, you're going to get a 2x minus 3 minus a 4x minus an 8. So it's going to be a negative 2x minus 11. So I end up getting that this is a 2x minus 3, a negative 2x minus 11, and on the bottom it's a 2x minus 3 to the 4th. One of these can cancel, and my final answer would be negative 2x minus 11 over this 2x minus 3 to the 3rd. Now, you absolutely could have foiled out the entire, foiled out the denominator and then tried to find the derivative that way, differentiate that way. You would have gotten an answer that looks very, very different. And it eventually, it would have looked similar to it would have basically been this answer, but completely foiled out, right? With the 4th power on the bottom, and it would have been really, really pretty ugly. Here, it made a lot more sense to just do a chain inside that quotient, right? So let's do another one that is something like a product or a quotient that has a chain. So, for our P4, instead of doing a quotient, let's do a product, right? So P4, I'm going to give you f of x equals 2x minus 1 to the 3rd times 3x plus 4 to the 2nd. Okay, so now what you're going to do is you're going to find f prime of x. So this is a product where both of the u and the v have a chain, right? So this is a product. So pause me if you want and give this a try on your own, or if you want, go ahead and watch. Either one's fine. So in this situation, this whole thing is my u, and this whole thing is my v. But in the u, there is an inside function, inside, and there's an outside function, which is stuff cubed, right? And inside the v, there is an inside function, and there is an outside function, which is stuff squared. It would be a terrible idea to FOIL this out. It would not be impossible, but it would be a really bad idea. So my f prime of x is going to be u dv, which is going to have a chain, right, plus v, and then du, which is also going to have a chain, okay, because it's a function inside a function. So let's start with u. So u was the 2x minus 1 cubed, right? And then dv is going to be 2 stuff to the first, you don't have to write the 1 power, times the derivative of the stuff. The derivative of that inside would be 3, right? And then over here we have v, which is the 3x plus 4 to the second, right? And then du is going to be 3 stuff to the second, so 3 stuff to the second, right, times the derivative of the stuff, which would just be a 2. Now, here's the crazy thing about this. If you did FOIL all this out, you would get an answer, but your answer would be this huge unfactored polynomial. But by doing it this way, I'm actually going to be able to find a bunch of GCFs, okay? So let's look at what this looks like before we factor. I move the coefficients to the front. I have a 6 times 3 of these guys and 1 of this guy. I'm not going to FOIL things out, and I'll show you why in a sec. Plus a 6 times 2 of this guy. Oh, here, let me put them in the same order. I'm going to put this guy first. 2 of this guy and 2 of this guy. It doesn't matter what order they're in, I just think it looks prettier this way. Okay, so now I have a huge GCF. There is a giant GCF. Okay, that GCF includes a 6, because both of these have a coefficient of 6. Okay, it includes 2 of these, because this one has 3 and this one has 2, so I can pull 2 of them out. Okay, and it includes 1 of the 3x plus 4s, because the largest number both of them have is 1. This whole thing is a giant GCF. And once I take that out, the only stuff that's going to be left, right, if we talk about my leftovers, which is not a math term, but you know, I took out the 6, I took out 2 of these, and I took out the only one of this that there was. So I have a 2x minus 1 left in the first term. Plus, I took out both of these, and I took out one of these. So I get a 3x plus 4, right? I don't even need the parentheses because there's plus in front, but you can have it if you want. So it looks to me like my answer ends up being a 6 times the 2x minus 1 quantity squared times the 3x plus 4, and then I can clean this up. This is going to be, if I go ahead and lose the parentheses, because at this point they're not doing anything for me, there's nothing to distribute, I get a 5x plus 3. And now I have a fully factored expression. Now, if you had FOILed everything out, you would have gotten an answer that would have been right, but it would have been very difficult to use. So, again, using this as a chain rule is way smarter, right? There are other ways to do this problem, but it would have been incredibly hard to factor the other version of this problem, and this is already factored for you. So that's an example of using the chain rule that's really, really useful. All right, so let's see. Cool. So, let's see. That was example 4, P4. Okay, so example 5. All right. Let's do it as a cube root. Okay. All right, so f of x equals the cube root of the quantity x squared minus 4x. Okay, so what we're going to do, so 1, we're going to find f prime of x. 2, we are going to find all x for which f prime of x equals 0. And then 3, we are going to find all x for which f prime of x is undefined. meaning f of x is not differentiable. Cool. All right. So let's go ahead and walk through this together, and then we'll do a similar one with a P5. Okay, so yet again, we're going to see that it is way easier if you rewrite your root as a fractional exponent, okay? So you're going to rewrite this as a 1/3. This is definitely a chain rule, because you can see that you have a function on the inside, and you have that cube root, or the power to the 1/3 on the outside, right? So let's go ahead and find f prime first. And this is going to be a situation where it's beneficial to us to simplify. So my f prime is going to be the derivative of the outside times the derivative of the inside. So the derivative of the outside is going to be 1/3 stuff to the negative 2/3, right? Because it's 1/3 minus 1, which would be 1/3 minus 3/3, times the derivative of the inside, which is going to be a 2x minus 4. So while this is a correct answer, you're going to find that this is not particularly useful to you in trying to move forward with this problem, in doing literally anything else, right? So I'm going to suggest that you want to go ahead and put this guy on the bottom where he belongs, and you're going to get a 2x minus 4 on the top, and a 3 times this x squared minus 4x to the 2/3 on the bottom, okay? So I'm going to suggest that this is the more useful version of f prime of x. You could also rewrite it with the cube root, but I'm going to argue that it's easier to leave it like this. Okay, next step. We're asked to find all x for which f prime of x equals 0. Okay, so if a fraction equals 0, it's the numerator that equals 0, and I can show you why. If I set this x, or this f prime of x equal to 0, right, the first thing I would probably want to do to solve is multiply the denominator over. So I'd multiply this over to the other side. Well, 0 times a bunch of stuff is totally just 0, right? So I'm going to end up getting that 2x minus 4 equals 0, which was totally just the numerator. So if you have a fraction that's equal to 0 and you want to solve it, you really just need to know when the numerator equals 0. And so when I add the 4 over and divide by 2, I'm going to get that the only answer is when x equals 2. The second, or the third part of the question is find all x for which f prime is undefined, meaning f is not differentiable. Well, f prime is undefined is saying that f prime of x equals a number over 0, right? It's saying that you're dividing by 0. So really, that's code for saying set your denominator equal to 0 and solve. So 3 times x squared minus 4x to the 2/3 equals 0. So this is already factored, right? Sort of. It's either 3 equals 0 or this whole thing equals 0. So since 3 can't be 0, I get that x squared minus 4x to the 2/3 is 0. You get rid of the 2/3 by raising everyone to the 3/2 if you feel you need to, but either way, you get x squared minus 4x is 0. When you factor this, you take out a GCF of x, and you get that there are two answers. Either x equals 0 or x equals 4, right? Because it's x equals 0 or x minus 4 equals 0. So there are two places where this graph is not differentiable. So if we were to actually look at what this graph looks like, what you're going to find is that at both of these locations, something weird and so like a vertical tangent or a point or cusp is happening. Cool. So that's kind of the gist for our E5. I really want to show you that on my calculator, but I just realized my calculator is in the bin that the computer is currently sitting on top of. So we're going to go rogue here a little bit and lift up the lid and hope that we don't totally wreck the setup. Can't make any promises. Okay. Great. Good enough. Okay. So if I show you what this looks like, right, if I want to put this in my calculator, you're actually going to put it in like this. So you're going to put in the x squared minus 4x in a parentheses, caret 1/3. There is a cube root, but it's easier to put in like this. And I'm going to go ahead and zoom 6. So here's what you're going to see the graph look like. Okay, so you're going to see that it actually is a vertical tangent at both of those points. So interestingly enough, if we just look at these two options, right, I'm going to erase this for a sec. Probably shouldn't have, because it would have been useful for P5, but that's fine. So this graph essentially looks like this. 1, 2, 3, 4. Okay, so basically what this graph looks like is it has a horizontal tangent, right? So f prime of 2 is 0, means that f of x has a horizontal, sorry, that's not how you spell horizontal, horizontal tangent, Okay, so the graph has like a horizontal tangent line. And then these two were vertical tangent lines. So it's a terrible version of the drawing, but this is essentially what was happening. So, so f prime of 4 was undefined because there's a vertical tangent line. And the same thing is true at f prime of 0 is undefined because there's a vertical tangent. So what we're going to find is that very often in calculus, we are asked questions about when f prime is equal to 0 or when f prime does not exist. And that's going to happen a lot. So f prime is undefined or f prime does not exist. We're going to be asked that stuff a lot, right? So, so again, f prime does not, and I shouldn't even say f prime is as undefined. I should go with the easier option of telling you correctly that it's f prime does not exist. Right, so f prime does not exist because f is not differentiable at those points. Anyway, so we're going to try a P5 that's similar, and then we'll wrap this video. But this is a good example of using the chain rule in a problem where you're asked to do other things, right? The problem didn't expressly ask you for the chain rule. It asked you questions about f prime, but in order to find f prime, you have to do the chain rule. Okay, so let's do a similar problem. Let's do... Okay, so P5. All right, I'm going to give you g of x equals the, let's do the, like that. Let's do the cube root of x squared minus 5x plus really minus 6. Good times. Okay, x squared minus 5x minus 6. And so I want you to find g prime. 2, I want x's where g prime of x equals 0. And 3, I want the x's where g prime of x does not exist. Okay, so again, you can pause me if you want. I'm going to walk through these examples, and yeah, that's my whole plan, so pause me if you want. So the first thing to remember is that you're actually looking at an x squared minus 5x minus 6 to the 1/3, right? So again, I have an inside function, and I have an outside function that's a 1/3. So my g prime of x is going to be 1/3 x squared minus 5x minus 6 to the negative 2/3 times the derivative of the inside, which is a 2x minus 5, right? So the easier way to look at this probably, and I'll give myself a little bit of room in a sec to do other problems, is to put this stuff on the bottom and get 2x minus 5 on the top, and the 3 times this x squared minus 5x minus 6 to the 2/3 on the bottom, right? So that's probably the way you're going to want to look at this. Now remember, what we're asking when we say g prime equals 0 is saying the numerator equals 0. So 2x minus 5 is 0. You're going to get an x that's 5 halves. And we will graph this in a second, the calculator. All right? And when you want to know when g prime does not exist, that's saying your denominator equals 0. Right? So since we know 3 isn't equal to 0, we can go ahead and divide that out, or you can just recognize 3 is not the same as 0. So, and when you put this whole thing to a power, you're really going to get the factor that you need to equal 0, because you could raise this whole thing to the 3 halves, is x squared minus 5x minus 6. You can get this answer either by factoring or using the quadratic formula. You're going to get an x minus 6 times an x plus 1 equals 0. So you're going to get that x is 6 and x is negative 1. Okay, so the two spots where you're going to have those tangents are at 6 and negative 1. And if we put this in the calculator, I'm basically putting exactly the same thing I did. I'm just changing my x squared minus 4x to an x squared minus 5x, and then inserting a minus 6, right? So it's still to the 1/3. So it's the same thing. And I go ahead and hit graph. And you're going to see that I have a horizontal tangent at 5 halves and a vertical tangent at negative 1 and 6, just like we talked about. Okay? So there's your P5. And we'll end this video on that, and then keep going after this.